Hello, this is Bongani with the online learning channel for Maths grade 10. So here in this video we'll be starting with our work for term 2. We'll be looking at this topic called functions. Under functions, I'll firstly introduce what functions are, then we'll start looking at what we call linear functions, quadratic functions, hyperbolic functions, exponential functions, trig functions, and interpreting of graphs. Interpretation of graphs. Right. So these are the topics that we'll be doing under the functions main topic. So first things first, let me define what functions are. So we're saying that a function is a mathematic relationship between two variables where every input has one output variable. Right. So here we are saying that if we are having an input x and then we plug it into some magical system, then we end up getting one output given by the variable y. Right. So let me make an example of what I'm saying by that. So let's say we are having something like this. So here will be our inputs x, and then this will be our outputs y. So if our input is 3, and then we are told that the system, for us to get the output, we take the input and then we add 3. So if we're gonna use 3 as our input, that means wherever we'll be seeing x, we'll plug in 3. So here it will be 3 plus 3. That means our output will be 6. If our input was 5, if we plug that into our formula here, it will be 5 plus 3, giving us 8. So that's how functions work. We will map it with this one-to-one relation, whereby one input produces one output variable. Also on this part of variables, we call this input variable our independent variable, and then this one is our dependent variable. So we're saying this is independent because we can control this input. So we can control this variable. So if we want this to be 12, we can plug in 12 and then into this formula, and then we'll get another answer which will be 15. This is a dependent variable because this output depends on whatever input that was plugged in. So this always depend on the input. So we cannot change this. For us to get the output that we want, we have to control the independent variable. So we call this our independent variable. This is the one that we can control and change to our liking, and then we call this the dependent variable, which depends on whatever input that we had at first. We have a couple of notations to go through. So that we understand some text whenever we see it under functions. So we have what we call the set builder notation. And then we also have what we call the interval notation. Set builder notation and interval notation. For the set builder notation, this is how we write it. So if we're given x, we'll say that it's x for all, where x is an element of real numbers, and then we define that our x is greater than 0. So this is how we write it. So we're saying whatever variable we have, so x in this case, it's an element of real numbers, and then we are saying that all the x values that we are focusing on are values that are greater than 0. So that means, since we are looking at real numbers, that means we start looking at your 0.000, maybe 1 somewhere down there, and then we continue with this up to positive infinity. So this is what we are saying by this statement. It has to be great, x has to be greater than 0, and then x has to be a real number. This is how we write that. Right. So another format we can use, let's say, let's look at this in a number line. Let's use a number line. So we are given -2, -1, 0, 1, 2, and 3. And then we are told that this is shaded, and then this is open like this, and this is our number line. So we are saying that the x value, or the values that we are looking for, exist in this interval. So if it's shaded like this, it means that whatever number we're looking at is included. So that means we're saying whatever value is equal to -1 or is between these two values. So if, let's say, this was our variable y, we'd say that y such that y is an element of real numbers. Y is an element of real numbers, and then y is greater and equal to -1, but y is less than 2. So this is how you would write, you'll translate this part to the set builder notation. For the interval notation, we use two types of brackets. The curly brackets, this is for not included, and then the square brackets are for included. So looking at the same examples here, if we were supposed to write this in set builder notation, we're gonna say that our x is from 0 0 is not included because we don't have an equal sign down there, so it's not included, up to infinity. Infinity is also, positive infinity is also not included because we don't know where positive infinity actually ends. So this would write, if we were supposed to translate this from set builder notation to interval notation, this is how we would write it. If we were supposed to move this to interval notation, we would say that -1 is included, so we'll plug in a square bracket, and then 2 is not included, so that will be a curved bracket like that. So this represents all of this in set builder, in interval notation. So those are the notations that we need to understand. One other notation that we need is called the function notation. Function notation. So if we are given something like f3 like this, so this means f at x, it's equals to x plus 1. We'll get into what these functions are in a short while. So right now I just wanted to show you what this means. So this is saying f is a function where that depends on x. So x is our independent variable. This depends on x to give us the output. So if we are saying f at 3, we are saying wherever that you are seeing x, just plug in 3. So this will be 3 plus 1, giving us 4 like this. So if we were given f0, this would be 0 plus 1, giving us 1. So this is how you look at function notation. Another notation we can look at, it's still under function notation. If we were told that f at x, it's equals to 30, then that means the output is 30. We're supposed to find the input. So in this case, this is our function. That means solving for x, we'll just transpose 1, so it will be 30 minus 1 equals to x, and then we end up with x being 29. So that means if we were looking for the variable x that we were supposed to plug in here to get 30, it would be 29. So that means if we are looking at f29, that means we'll be having 29 plus 1 giving us 30. So this is another way of seeing this. So here we are given the input, we are looking for the output. Here we are given the output, and then we're supposed to find what the input variable was. So this is how you do that. We have another term we call the domain, then the other one we call the range. So the domain, these are all the x values where the function exists. These are all the y values where the function exists. So here we'll be looking at your your dependent variables, because these are y values. So we'll be looking at your dependent, and then here we'll be looking at your independent variables, like that. Right. One way for us to look at functions that we usually use, it's called the table method. So let's say we were given that function that we had earlier, f at x is equals to x plus 1. So we draw a table. These are all the x values, so these are your inputs, and then these are your outputs. So if our input is 0, we plug in 0 here, we'll get our output as 1. If our input is 1, if we plug in 1 here, we'll get 2. If our input is 3, if it's 5, if it's 10, so that means we'll plug in 2 here, so it will be 2 plus 1 giving us 3. If it's 5, it will be 5 plus 1 giving us 6. If it's 10, that means this would be 10 plus 1 giving us 11. So let's carry on. Let's say we are given the output as 30. We want to find the input variable. That means we would say x plus 1 equals to 30. Therefore x is equals to 30 minus 1, and then this is 29. So that means we would need to have an input of 29 here to get an output of 30. So this is what we call the table method. We'll be using a lot of tables to figure out our functions. Right, let's start talking about linear functions. So we have what we call linear or straight line functions. Straight line functions. Linear or straight line functions, and then these are functions of the format y is equals to mx plus c. Right, so here basically we're just drawing a straight line using this formula. So this formula guides how our line is gonna be drawn on what we call our Cartesian plane. So I'll explain these in a minute. So this is our output. This is what we call the slope or gradient. Slope or gradient, I'll explain what that is. And then this is our input variable, and then this is what we call our y-intercept. Right. The output variable is still the same output that we've been talking about right now, and then the input is still the input that you know, and then the slope or gradient determines how the incline of the line would be. So it's the change in y variables, so we call that m. It's the change in y over change in x, which is the same as y2 minus y1 over x2 minus x1. So let me explain that. So let's say we have, this is our Cartesian plane, x-axis, y-axis. And then we'll have 1, 2, 3, 4, 5, and then this side are negatives, -1, -2, -3, and so on. And then this side it's negatives, -1, 2, -3, -4, +1, 2, and 3, like that. So for us to find the slope, would look for any 2 points on the line, so any 2 points on that fall on the line, and then we'll call that your 2's, and then the other one would be your 1's. So let's say this is our line. So this is 1 point, and then this is another point. So this point, we start with the x coordinate, so it will be 3 and 2. This point will be 0 and 0. So for us to get the slope here, we would say m is equals to y2 minus y1 over x2 minus x1. So if these are our 2's and then those are our 1's, that means we would say y2 is 2 minus y1 is 0 over x2 is 3 minus x1 is 0, like that. So that means our gradient is 2 over 3. So that's our slope. That's how our line let's do this. That's how our line is inclined from the x-axis. So it's 2 units up and 3 units to the right. So that's our slope over there. We'll get a hang of the slope term as we go along into more and more examples. Right. So now we have that as our slope. Now let's try and find the equation of this line. So we know the slope, so y is equals to 3, it's 2 over 3 x plus c. Now we are looking for this c term, which is our y-intercept. So for you to get the y-intercept, in this case we have to substitute one other point. So let's plug in this point 0 and 0. So that means wherever we'll be seeing x, we'll plug in 0. Wherever we'll be seeing y, we'll plug in 0. So this will be 0. It's equals to 2 over 3 into 0 plus c. And then solving this, we end up with c. It's equals to 0. So that means the equation for that line, it's y. It's equals to 2 over 3x plus 0. So we'll leave it like that. Okay. And then another thing we have to look at is the effect of the slope. The effect of the slope. So if the slope is positive, then that means we'll be having a rising graph like that. If our slope is negative, that means we'll be having a decreasing function in this format. And then if our m is equals to 0, that means we are looking at a straight line in this format. Alright, so in the next video I'll show you how to find the intercepts, what we call the x-intercept and the y-intercept, and then we'll do a few examples on graphs, and then we'll look at the table method in detail, and then we'll start graphing our graphs from the tables, and we'll take it from there. Right, thanks for watching, guys. Tune in to the next video. This lesson was brought to you by Online Learning Channel.